today's notes, we are on section 8.3, and today's notes are on the discriminant. There's not supposed to be a dot between the I and the N, it just kind of happened. So today's notes are on something called the discriminant, and it's a part of that quadratic formula. So hopefully we have that quadratic formula memorized, right? Remember our songs? Nice! Good job, Sweta. That was awesome. All right. So our quadratic formula, remember let's think about the weasel song. Our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. I would sing it, but I have a very bad singing voice. Good job. Carson's got a very nice singing voice. If I start like singing in the car, even my husband will like tell me like, please don't sing anymore. So no, I can't. Guys, we're a little bit chatty today. All right, so within this quadratic formula, since there's a plus minus, how many answers will we have a lot of the time? 2 answers. Now there's one part of this formula that really determines how many answers we're going to have. And it is what is inside the square root. So this b squared minus 4ac, that's a really important part of the quadratic formula because it's going to end up telling us how many answers we have. And the name of this part of the quadratic formula is the discriminant. No, it doesn't discriminate, people. It's the discriminant. And it's going to tell us how many answers we're going to get. So it's going to tell us how many times that U-shaped graph crosses the x-axis. And it's going to tell us what kind of answers they are. Are they real numbers? Are they complex? What kind of numbers are they? So we're going to make, okay, if you guys can see on my paper, see how I made this like big table? So we're going to make something like that on your paper. It took up probably about a half page on my paper. So, in our first column, we're going to talk about the different types of discriminants we could get. Let's see, I'll try to use this straight line tool here. We're going to talk about the different kinds of discriminants we could get. In our second column, we're going to say how many and what type of solutions are we going to get with that discriminant. And then in our third column, we'll put an example of that happening. So we're going to have different discriminants. We're going to have some how many solutions and what type of solutions we'll get, and then we'll put an example of each one. So if our discriminant, if what's in the square root equals 0, so you've got negative b plus or minus nothing all over 2a, how many answers do you think we'll have? One answer. Nice, Clay. Yep, Clay did say that. All right, so if our discriminant, if b squared minus 4ac equals 0, so you've got the square root of 0. What's the square root of 0? 0. So you're not adding or subtracting anything onto the b, so it's almost like you could just forget about that part. It's just negative b over 2a. You just have one answer. So you just have 1 repeated, it's kind of like you have the answer twice. Rational solution. So remember, rational means it's going to end up being like kind of like a nicer number that we could make a fraction out of. It's not like pi. It's not some number that goes on forever and ever with no repeating or anything. It's kind of a nicer number. So an example of that would be, let's say your quadratic formula looked like this. -2 plus or minus the square root of 0 over, let's just say a is 1. So on the bottom we have 2 times 1, so just 2. So this is like a little example of what it would look like if that happened. Well, it would be -2 plus or minus, what's the square root of 0? 0. So it's just -2 over 2, which is -1. Negative divided by positive is negative, and 2 over 2 is 1. So when you have a square root of 0, you don't really even kind of need the plus or minus because you're not adding or subtracting anything onto it. So if your discriminant is 0, you only get one solution. It's rational. Okay, let's move on to some other things now. Let me fix that. All right, next row of our chart here. I use the straight line tool. I kind of cheated. All right, so now let's say in your square root, let's say you got a positive number and it's a perfect square. Like, what could it be? 16, 64, 24 is not a perfect square. 25, 25. All right, so let's say that when you did, hey guys, any chat needs to stop, okay? Let's say you did b squared minus 4ac, and you ended up getting a positive perfect square. So like in your square root, you had like 64 or 100 or 25 or 81 or 49 or 36 or 16 or 9 or 4 or 1 or 121, yeah. So if that happens, how many solutions do you think you'll get? Will you have two different things to add or subtract? Yeah, because you'll have like plus or minus, maybe it's like 8 if it was a square root of 64. So you're going to get two. Do you think the solutions will be rational or irrational if it's a perfect square? Rational. They'll be like kind of like nice. You'll get two rational solutions. And you do kind of have to like, memorize this chart, but hopefully it just will kind of make enough sense that you won't really have to memorize it. You'll just kind of, you'll naturally memorize it. So, I can't get much farther from my computer. I'm tethered. I know, maybe at the end of the year I'm going to treat myself to wireless headphones. So, every teacher's dream. So, for an example, we might have something like, for all these examples, I'm going to keep this -2 and 2 the same just to make it simple. We might have like -2 plus or minus the square root of 64, a positive perfect square, over 2. Maybe that'll help. So then, that means we're going to have -2 plus or minus what? We're going to have -2 plus or minus 8, good, over 2. And then remember, because last week we were kind of making this mistake where we put the plus or minus on our answer at the end. Jack, yes. So we've got to do -2 plus 8. What's that? 6 over 2, which is 3. And we've got to do -2 minus 8. What's that? -10 over 2? -5. Good. So 3 and -5 would be my two rational solutions. Getting all this down, Jake? You still paying attention? That is half of our chart. Half of our chart. We got 2 more rows left. Ooh, look how perfect that is. Nice. Oh, that one's a little off. Oh well. Alright, so our next possibility is we could have our discriminant, b squared minus 4ac. It is positive, but it's not a perfect square. So maybe it's like plus or minus the square root of 15, not a perfect square. 15 would be positive. Whatever's in the square root. I'm saying if that is positive, the stuff in the square root. What'd you say, Carson? Yeah, we're going to still get 2 solutions because we're still going to be adding or subtracting something right here. Like if it was the square root of 15 over 2a. So we're still going to have 2 solutions, but Carson's right. They're going to be irrational because since we don't have a perfect square, these numbers might go on forever. 2 irrational solutions. And I want to make a note that they're going to be conjugates of each other. Remember that vocab word? Like 2 plus root 3 and 2 minus root 3. Those are conjugates. So, for example, honestly, these ones are kind of nice when you get them, even though they seem mean. You could have like negative 2 plus or minus the square root of 11 over 2. And if we have a non-perfect square in there, and we can't break down that square root at all, right? 11 just breaks into, if we did the tree, 11 and 1, it won't go anywhere. Like, those are your 2 solutions right there. You can just leave it like that. So, honestly, those are kind of nice. But you do want to make sure you can't simplify that square root. Oh, sorry. This. Oh, yeah, that's true. I'm, like, afraid to move too much, though, because if anything comes unplugged, I'm afraid it's going to mess this video up. We have a lot of people absent. All the people in the French field trip. All right, one more row. Do I start recording? Okay, good. Man, if I would have known you guys would be this excited about math just by seeing it on a computer screen, I would have done that a long time ago. I know. It just appears. I know. I know. All right, so then what do you think our last possibility would be for b squared minus 4ac? Well, we talked about if it was 0, if it was a positive perfect square, if it was a positive non-perfect square, or if it is negative. So maybe our discriminant, that stuff in the square root, maybe it's going to end up negative. A negative in the square root. We're going to have 2 solutions. What kind of solutions are they going to be? What does I mean? What kind of number is that?
Imaginary.
2 imaginary. Good. 2 imaginary solutions. I'll move out of your way in just a second. And they're going to be complex conjugates. It's a vocab from our last chapter. Complex conjugates. So it might be like 2 plus 3i and 2 minus 3i. So, for an example, say we had in our square root a negative 2. So we have negative 2 plus or minus the square root of negative 2 all over 2. Lots of 2's. No. How can we have 4 if we have a negative in the square root. Yeah? Plus or minus positive b. Well, because remember, in the square root, it's b squared minus 4ac. So that could turn out negative. If whatever your b squared wasn't quite big enough, and when you subtracted that 4ac, it could go down to the negative. That's a good question, though. So then, if you ended up with this, remember, you can't write a negative in your square root as an answer, so what letter do we have to pull out of it? I, because that's the square root of negative 1. So this is negative 2 plus or minus I root 2 all over 2. Okay, do you want me to show you what you guys want to do right now? I know that you guys want to do this so bad right now. I know you all want to do this. Can you do that? No, because because you would have to be able to do heart method, right? You'd have to be able to divide this by 2. Oh, there's a 2 right here. Can I cross that out? Because is this a 2? It's the square root of 2. It's like 1.41 forever and ever and ever. So you guys, you can't cancel a 2 in a square root and a 2 not in a square root. Because that means you're saying that root 2 over 2 equals 1. But it's not. So we can't cancel anything here. Some of you guys were still doing that on your retake. I'm sad. So let me show you when you could do that crossing out the 2. Let's just say, you don't have to write this one down. Let's just say you got negative 2 plus or minus 2I root 2 all over 2. Now you could cancel some things, right? Because in this one, we can do heart method. This one we actually could. What's negative 2 over 2? Negative 1. That means that's why we can cancel them, because 2 over 2 is 1. And then here, the 2 over 2 is 1. So this is just plus or minus I root 2. That's the only time you guys can do that. Yeah? Uh-huh. Yes, you could do that. Yeah, you could do what Jack just said. What the heck? You could, I need a bigger eraser. You could take that solution that we got, and you could write that into 2 fractions. So he's saying you could do kind of heart method, negative 2 over 2 plus or minus I root 2 over 2. And he's saying on this one, you could make that a negative 1. So it'd be negative 1 plus or minus I root 2 over 2. So you can do that, yeah. You just can't, you guys can't cancel a 2 in a square root and a 2 not in a square root. Yeah? You don't have to. I'll let you guys leave your answer like that. Unless it says write it in the form A plus BI, which I was a little lenient on the test and I didn't take off for that. But next time we will. Alright, so let's do some examples. That was a lot of notes. Alright, so the first examples you guys are going to get are just going to say determine what type and the number of solutions. So it's not going to actually make you solve this quadratic equation and find what x is. It's just going to ask you how many solutions are there, what type are they. So you're going to want to refer up to that chart that we made. So we're going to do a bunch of different examples here. So for our first one, here is our equation. 9x squared minus 12x plus 4. So we're not going to actually set that equal to 0 and find the x-intercepts and find what x equals. We're just going to determine if we did do that, how many answers will we get. Jake, can you stop talking? You need to move. There's a C right here. Okay. You want to sit there, Tyler? You want to sit there? No, right here. Okay. All right, so what you guys are going to do on these is I want you to write off to the side what your A, B, and C are. Because those are all in the discriminant, right? B squared minus 4AC. You need all three letters, even just to find the discriminant. All right, what's our A in this one? B? C? Good. So now, since we don't have to actually find the solutions, we just want to know how many, all we have to do is the discriminant. All we have to do is figure out what B squared minus 4AC is, and that'll tell us how many solutions and what type. So let's see. Do you guys know what my B squared is? What's negative 12 squared? Good. 144, because negative 12 times negative 12 is 144. And then I think you should always write minus 4. And then if you want to multiply A and C together before you write it down, you can. So what's 9 times 4? 36. Good. Does anyone know 4 times 36 in their head? 144. So this is just 144 minus 144, which equals 0. All right, so then we can look back at our chart, or maybe we already know, if your discriminant is 0, so you've got the square root of 0, how many solutions do you have? One repeated rational solution. That's from our chart. So this means we're going to have one repeated rational solution. All right, so now we're going to have the same instructions here. We're going to determine how many and what type of solutions. Here's our equation. X squared plus 5x plus 8. We really should write equals 0, too. We need to know what it's equal to. So we're trying to figure out, like, how many solutions, meaning how many x-intercepts. How many times does this thing cross the x-axis? So we always want to write down what our A, B, and C are. And if you guys do this, it will help me figure out if you went wrong. It'll help us figure out where you went wrong. So in this quadratic equation, what's my A? 1. Good, there's a 1 in front of that x squared. What's my B? 5. Okay. And what's my C? Good. So now we're just doing B squared minus 4AC. All right, so what's my B squared? 25. 5 squared is 25 minus 4, and then we can put our A times our C. So what's 1 times 8? 8, yeah. So we've really just got 25 minus 32. Yay, we know our times tables. What's 25 minus 32? Yeah, it's a negative, -7, right? So if we get a negative answer for our discriminant, let's see, negative, what kind of solutions and how many? 2 imaginary, and you can just write 2 imaginary solutions. So how many times are you going to see that cross the x-axis, do you think? If it's imaginary solutions. If it was real, we would see it cross it twice, and this is not a really accurate representation of this graph, but it's going to be something like that. It's not going to even hit the x-axis, because when it hits it is imaginary. Okay, we've got one more of these and then some other kind of examples. 2x squared plus 7x minus 3 equals 0. All right, so we've got to write out our A, B, and C. You guys go ahead and try this one. I'm going to pause it.
What do I say?
Okay. All right, so
What do I
we're just
say?
going to solve our problem. We'll just go through and say, like, A is this, B is this.
Okay, A is 2, B is 7, and C is negative 3. And the equation is b squared minus 4ac. And 7 squared is 49 minus 4. 2 times negative 3 is negative 6. 49 plus 24 is 73. And since it's not a perfect square and it's positive, it's not positive. Oh, that kind of positive. I thought it was like even, yeah. And so that'd be 2 irrational solutions.
Oh man. Oh goodness. All right, find an equation for which the given numbers are I won't. Find an equation for which the given numbers are solutions. I get scared knowing that you guys can drive in like 2 years. Oh goodness. Okay. All right. So, first one. First one, we're going to try and find an equation, a quadratic equation, to where if we did the whole quadratic formula, the answers would be 3 and negative 2/5. This is easier than you think. It's easier than you think. So remember, one way we have of solving quadratic equations was factoring them, right? We'd factor it, and then we'd set each of our factors equal to 0. So let's just pretend these are the answers we got when we set things equal to 0. Okay, and I think you guys will understand this more once we do it. So this means we would have x, okay, what do I need to put? X, what, 3? If when I set it equal to 0, I want to get a positive 3. Good. If I have x minus 3 equals 0, that means x equals 3, right? Because I'm trying to figure out x something 3 equals 0. And I want to get 3. Okay? So then, what do you think I should put here? X what 2/5? Plus. So you just switch the sign right here. Okay? So, no, not really. So we're just basically setting up what we would have gotten after we factored it, working backwards from factoring. So it's like, these are our factors. This equals 0. Then we want to write this. We want to write this in the form of ax squared plus bx plus c, not like this. So what do we need to do here? Yeah, well, not factor, opposite of factoring. Foil or multiply it out. All right, so we need to practice this, I think. What's x times x? Okay. X times 2/5. 2/5 x. So I did our first number times both numbers in the second set of parentheses. Now what's negative 3 times x? Negative 3x. Negative 3 times 2/5. Negative 6/5. Because this is a 3 over 1, so we're just doing 3 times 2 is 6, and leave the 5th on bottom. All right, now can we combine any like terms? Yeah, we can do 2/5 minus 3, right? You probably need to do this out to the side. You guys cannot just ignore ones with fractions, all right? You're not getting full credit on homework anymore if you don't do the ones with fractions. So we've got 2/5 minus 3. To subtract fractions, do they need to have the same denominator? Yes. What do you want to change this denominator to? Yeah, let's multiply it by 5/5. So we've really got 2/5 minus 15 fifths. Raise your hand if you can tell me what 2 fifths minus 15 fifths is, Elise. Nice, negative 13 fifths. We can leave it improper, that's fine. So we've got x squared minus 13 fifths x minus 6 fifths equals 0. Guys, we need to stop the chatting. Now, here's a rule that I know you're not going to like. You can't, in a quadratic equation, we don't want to give it with fractions in it. We'd really prefer to give it with all whole numbers. What could I do to get rid of those fifths? Multiply everything by 5. We're going to multiply everything times 5. We can do that. All right? So what is x squared times 5? 5x squared. What's negative 13 fifths x times 5? Negative 13x. Because the 5 over 5 is just 1. And then what's this going to be? Minus 6. Good. Equals 0. That's it. That's not too bad. Yeah, see, it's really not too bad of a problem. These are long. All right, so we've got 3 more examples. Same instructions here. We're going to find an equation that has the solutions 2i and negative 2i. We're going to do the exact same process. But yeah, we know I is a square root of negative 1. So raise your hand. What should I make my 2 factors? What should I write in those parentheses? Look at the way we did it last time. It's going to be just the same. Tyler? Yeah, x plus 2i. Technically, I'm going to write it the opposite order if that's okay. Just so you guys can see what... So this one gives me an x minus 2i. And this one gives me an x plus 2i because I'm doing the opposite sign that I see. Okay, let's multiply this out. A lot of us need to practice this still. So we're going to do first, what's x times x? X squared. Outer, so what's x times 2i? Yeah, 2ix, or you kind of want to write 2xi. What is negative 2i times x? Negative 2xi. Okay, now this is where we got to be careful. I've seen a lot of mistakes on this, even on our retakes. So what's negative 2i times positive 2i? Negative. Negative times positive is negative. 2 times 2 is 4. I times I is I squared. A lot of us are forgetting that I squared. Right, right. So this is going to change. Hey guys, if we are chatting, we need to stop. So, some people are telling me, first of all, what happens to 2xi minus 2xi? That's 0, right? So we've got x squared. What is negative 4i squared going to change into? Plus 4. Because I squared is negative 1. So this is negative 4 times negative 1. So it's just plus 4. So x squared plus 4 equals 0. There's your answer. So honestly, the ones with i's in it are kind of nice. All right, 2 more examples. So we're going to find an equation with these 2 solutions. 5 root 7 and negative 5 root 7. I would have you guys do this one, have someone come up here and do it, but we're kind of running out of time. These are long today. Raise your hand if you can tell me what my 2 parentheses should say. X. Let's do the minus first because it goes with this one. X minus 5 root 7 and x plus 5 root 7. We really need to be careful when we multiply these. A lot of us are not taking the time to be careful. Now, when we multiply it, could we just use a shortcut on this one? We could have on the last one too, right? Because this is a minus b, a plus b. It's a difference of squares. So what is that going to multiply into? A a squared minus b squared. Difference of squares. So here's my a, and here's my b. So what's a squared? Good. What symbol is always going to be in between? A minus. It's always a minus. Now we've got 5 root 7 squared. You might want to write this out because we've been making some mistakes when we try to do this in our head. 5 root 7 squared. Now let's figure out what that is. So we've got x squared. Remember, in this situation, we actually can distribute that power because there's no plus or minus in here to mess it up. If there was a plus or minus, it would mess it up. So what's 5 squared? What's root 7 squared? 7. So we've got 25 times 7 right there. How much is 7 25s? Good. So we've really got x squared minus 175 equals 0. Good. Okay, we've got one more. Okay, this one is going to have 3 solutions. Negative 4, 0, and 1. This one's tricky. There's 3 solutions. So here's what I want us to do. If we have 3 solutions we're trying to get in there, if one of them is 0, I want you guys to forget about that one for a second, because that one's going to be actually easy. So let's just do, no, you can't do that. Let's do the negative 4 and the 1. So what should be in my parentheses for the 4, for the negative 4? X plus 4, and what about the 1? X minus 1. Good. So now we're gonna come back to that 0 in just a minute. So now we need to multiply this out. So x times x squared, outer x times negative 1, negative 1x or negative x, inner 4 times x, nice, and last 4 times negative 1, negative 4. Can we combine any like terms? Yeah, what's negative x plus 4x? Good, so x squared plus 3x minus 4. Now, that's going to give us those 2 solutions of negative 4 and 1, but we also wanted a solution of 0. Do you guys know what I could write right here to make sure that one of the factors would equal 0? No, you can't. No, we want x to equal 0. So this would make x equal negative 4 if I set it equal to 0. I can put an x on the outside because then I would get a 0. I would get x equals 0. I would get x equals negative 4 from this guy, and I would get x equals positive 1 from this guy. So if we just stick an x on the outside, that factor will be equal to 0 if we set it equal to 0. So that means we just need to multiply all of this by a factor of x. Because if we set it equal to 0, this factor would have to equal 0. Because we would take each separate factor, this and this, and set it equal to 0. So now we actually need to multiply that. So what's x times x squared? X cubed. What's x times 3x? 3x squared. And what's x times negative 4? Negative 4x. There we go. So we got that x equals 0 solution on there too. All right, so let me stop this.